Welcome to Think Global Education Services. In this video, we are going to talk about dispersion forces or intermolecular forces of attraction. These are the fundamental forces of attractions that are present between the molecules in any stable compound. The basic idea and the concept of intermolecular forces arises from the thought: how do molecules act together? Because we know that molecules are formed by means of a chemical bond when the atoms share their electrons. And also, compounds are formed when electrons have been transferred from one element to another element. So now, when we consider as a whole a substance of 10 grams or 100 grams, how the atoms and the compounds are present together. What is the force that has been holding the molecules in this 10 gram of a substance? Then it is understood that it is mainly because of the weakest intermolecular forces that exist between non-polar molecules such as the hydrogen, chlorine, and the sulfur, because of which the molecules are together. Or the non-polar molecules exhibit a weak intermolecular force of attraction called as London dispersion forces. This arises when the electrons around the nucleus of an atom occupies the position in such a way that makes the atom form a temporary dipoles or the instantaneous dipoles in a molecule. Because of the constant motion of the electrons around the nucleus of an atom, the molecule or an atom develops a temporary dipole when the electrons are unsymmetrically distributed. Resulting in the formation of the instantaneous dipole and increasing in the force of attraction. These London dispersion forces are the attractive forces that causes nonpolar molecules such as nitrogen, halogens, the gaseous substances, exhibit a property such as condensation of liquids, condense to liquids, and freeze into solids at lower temperature. As an example, the nitrogen gas liquefies at a lower temperature such as 196 degrees Celsius, and also helium can be liquefied at minus 269 degrees Celsius. The physical properties of the elements can also be explained by means of the London dispersion forces. As we can see in the table over here, London dispersion forces will be increased in the molecules with increase in the molecular mass or atomic weight due to the increase in the number of electrons. When the number of electrons in a molecule increases, there will be an increase in the London dispersion forces in the molecule because of the increase in instantaneous dipoles in the molecule. Resulting in the increase in boiling point and the melting point of the compounds with increase in the molecular weight. This can also be accounted with the homologous series in case of the organic compounds. With increase in the molecular weight, in case of the organic compounds, the boiling point increases because of the increase in the number of electrons in the compounds. Thus, London dispersion forces is a weak intermolecular force that holds the atoms in a molecule, the nonpolar molecules, to be present together